This question says, let S be the set of all non-zero real numbers alpha such that the quadratic equation alpha x square minus x plus alpha equals to 0 has two distinct real roots x1 and x2 satisfying the inequality. So we have to find out the correct interval in which is a subset of S. So the given quadratic equation is given alpha x square minus x plus alpha equals to 0. So we can write it as x square minus x by alpha plus 1 equals to 0. This has two roots x1 and x2. So from here I can say that sum of roots x1 plus x2 equals to 1 by alpha and product of roots x1 x2 equals to 1. Now it is told that this satisfies the inequality x1 minus x2 modulus is less than 1. So what I am doing is root under x1 plus x2 whole square minus 4 x1 x2 less than 1. So it is 1 by alpha square minus 4 under root less than 1. This is 5 alpha square minus 1 greater than 0. So from here I can say root 5 alpha minus 1 and root 5 alpha plus 1 is greater than 0. So from here I am getting alpha is less than minus 1 by root 5 and alpha is greater than 1 by root 5. Let us name this as equation number 1. Now it is also given that roots of this quadratic equation are real. It is given roots of the equation are real. If roots are real, we have to find out d is greater than 0. Doing this, if d is greater than 0, we are getting 1 minus 4 alpha square greater than 0. From here alpha belongs to minus half to half. Let us name this as equation number 2. So finally, after doing 1 intersection 2, we are getting alpha belongs to minus half comma minus 1 by root 5 union 1 by root 5 comma half. Going back to the options, we have to find out which of the following intervals is a subset of S. So definitely option A minus half comma minus 1 by root 5 and option D 1 by root 5 comma half. These are the subsets of S. So option A and D are the correct answers to this question.